Hi all, I'm Vijay Jithani. So in today's session, which is on design and implement source control strategy, we are going to cover following topics. As you have seen in our previous session, we covered for process and communication. Now today it will be on source control strategy. Okay, so source control has to do more on repositories, how you work around with your commits, how you work on with your pull requests, how you review your codes and all those things. Okay, so whatever you are going to see from exam construct as well. So let's go topic by topic. So first topic says like design and implement branching strategies. Okay, so within that we will see how do we design the branch strategy and what basically the feature branch and release branch means to us. Okay, so we have covered brief in our previous session, but here we are going to talk more on that and also look at how basically you are going to review your code and comment and accordingly approve before getting promoted to production. Okay. Similarly, we will look into the branch policies and what that makes sense to us. Like from an example, say there will be short questions around branch policies and the protection. So you should know what exactly are the settings available to us, whether you are using Azure repository or you are using the GitHub. Okay, so all these things we're going to cover. Now in second topic, we have configure and manage repositories. So this has to do with basically if you are committing any binary files or what kind of the tools are available to us for deployment or how it works in the Git ecosystem. Okay. Similarly, we're looking at scalar. So this is more on optimizing your repositories for the larger files, or I would say when the repository storage is constrained in some way or other. In that case, your file system will be working very slow. Okay, so we have to see what this tools does to us and see from exam point of view, as I've already said in our session 1 also, that you are not be provided with any hands-on labs to do. Okay, but if you are working hand in hand while we are covering this session for the hands-on labs, that will help you understand the topic very well. So if you want to try out each and everything whatever we are discussing, do along with the session so that you understand the terminology, you understand the facts that yes, really this is happening at the back end while we are also working through the concepts. Okay, so make sure for everything whatever is covered in the session you try it out as an hands-on lab. Okay, moving ahead, I think we will also see in how the permission look like in source control repositories and how the tags are important from an to organize our content or group our content in a specific uh, topic. Okay, so that is where I think we will cover most on the repositories, and obviously we have to recover using git commands. So I'll be providing you what are the git commands available to us and how you are going to try. So there will not be any UI for that because see at a front UI level it becomes very difficult to get all the histories or all the comments, even fetch to for a one particular file. So that is the reason most of the time while you are trying to recover or restore something, you have to rely on CLIs. You cannot do anything from the front end. So make sure you are ready also to try on the git commands using CLI. Okay, because that will help you to get confidence on what exactly you are going at the back end. Because today, even though we have having GitHub, GitLab, and other front ends, but still they have not reached to the stage where they can do all these things from the front end. Also doesn't make sense because if you have to really fetch on UI all those comments, or I would say fetch all, even for a single file, if I want to fetch all the history of whatever has done for the one past year. So that is the reason I think it is becoming difficult from a UI per se to get that, but from the CLI I think it is just getting that comment or I would say a hash code for that particular comment, so that you are able to recover or you are even able to restore from that particular hash comment. Okay, so make sure at this point of time you are understanding the terminologies, and accordingly we cover for our exam. Okay, and last is for how you remove specific data from source. Now this is more to do with basically if you are have either committed something which was not supposed to be committed, like your passwords, or also some code which is a legacy, or I would say your own IP. So you should not commit if this is a public repository. So make sure you are able to remove that, and what are the guidelines and instructions to remove that code. So that is what we are going to cover in this particular topic. Okay, so that's brief about what exam or how you will be tested on exam. Okay, so now based on this, as we did in our session one, we will have our own agenda. Okay, to cover topic by topic. So coming back to our agenda, these are some topics which aligns to what exam is asking for. Okay, so at first place we will going about why source control. Okay, why basically we need source control system and what are the types of source control system available to us. Once we are aware about the terminologies and basic around that, then we will look into the branching strategy. So we will go through them. We will look at cloning versus forking, how that is different. We will work on pull requests and issues, and branch policies, merge restriction and protection, single repository versus multiple repository when you want to create that, and you want to have permissions in applied in the repository. That also we will cover tags. You will recover specific data using. Similarly, if you have commented something, you have can remove the specific data from the source control system, and at last the scaler for large repository. This is a tool optimization as we have seen. So bare minimum, this agenda covers all of your topic in a understandable sequence. Hence this agenda is I normally try to modify the agenda so that we get a flow proper, and accordingly we are going to move further on our learning sessions. Okay, so let's move ahead step by step. At first place, why we need source control. So you have seen a DevOps as a cycle, right? Right from developing your code and commenting it, getting it reviewed, and also making that available to your pipelines or workflows. At every stage, you need some source control system to be there. Otherwise, none of your able workflows will be able to work. Similarly, whether you are doing a feature related work or reviewing or doing anything across, even with the project management, you need something to cling to. Okay, so that is where, if you see in this diagram also, right from your version control, build, your unit test, deploy, all of them are tried attached to your source control in such a way that at any point of time either you're consuming that as a source or you are providing a package as to sync to the source control system. So hence it is very important that this is available to you at all times while you work on complete DevOps as a life cycle. Okay, so if you read out the bulleted points, source control is nothing but tracking and managing the changes to the code. It provides you a running history of the code development. That's correct. For it not only does for repository, it gives us for file by file. Okay, so we are aware like down the line what it was at 1 month back, now what it is at this point of time. Okay, similarly if there are any conflicts, it gives you that this is what is causing the conflict, and obviously there are few conflicts which you have to resolve manually and delete them or modify them in such a way that it is resolved. Unless and before unless you resolve that, you are not able to comment the future code. Okay, so that is there so that at any point of time you have clear and clean history of the code whatever you have commented on your branches. Okay, or repository. Now one thing was from having the history. Other thing is if something goes wrong or you lost your code on your machine, development machine, or something happens from a catastrophic event per se, or some any error has been committed, we want to recover that back. So that is where these comments or hash codes we are able to reutilize and able to restore them back with the help of the source control history. Okay, so at the end of the day, what we are getting out of it, we are getting reusability, traceability, manageability, and efficiency, collaboration, and is what we are getting out of source control as a system. Okay, and any pipeline or workflow requires that we already talked about. And continuous integration is that that's correct. That is the reason I said that either you're using your source control management system as your source or sync while you're creating a packages out of build, or even for your releases you store in some source control management system and take it as a input while you are actually deploying it on the any of your systems. Okay, so at this point of time, if you see, this is irrespective of even which particular stage you are of the DevOps lifecycle, source control system is must. Okay, so I will pause here for a while, you have a look, and then we will continue. Okay, so this was about why we need a source control system. Now, it is also important to know that what kind of the control systems or different types available to us. So first is centralized source control system. Now, this was more of a legacy, the way we were using your file shares. Okay, so file shares were more of a centralized source control system with a limited version control it has at the file level. Okay, now this is helpful. If you see the strengths, this is very helpful for a large code base because it is not scattered around different file systems, or I would say different shared drives. That makes sense. Also, as this is a single file system, you can control the permissions and also monitor its uses. Okay, and allow it for excessive file locking so that no one overrides. That means file locking is something that if I have logged this file because it is a centralized system, no one will be able to overwrite it. But simultaneously, this is also a disadvantage because in an agile system there are n number of developers working on your production code. Okay, so if they are working, they should have some kind of a parallel branch, a feature branch, or their own developer branch where they can comment and then can review their codes. So from a centralized system, I think it was a limitation. Hence, we have moved to the distributed version control system. Okay, but still, if you are a small team and really are able to make sure that uh, you are able to take care of your the coding, then you should go for it. Or you don't want to invest into any professional software, you can still go on it. But I think the pros and cons we just talk about, that you won't be able to have a branching strategy kind of thing where you are having the multiple commits or a review system in place. Okay, so that is a limitation. That is what here it is in single central copy for everyone. Okay, so irrespective of whatever you do, it is a single copy. Similarly, the I think whatever being used from a legacy, they were called a TFVC, CVC, subversion, and purpose. These are some examples of your centralized source control system which are available till date. While today, practically speaking, no one is using that. But having said that, the reason I told you that this is or this was the process which was followed at some point of time in back. Okay, so you should be aware of at least this, what are the centralized system available to you. Okay, so again I will pause here for a while. Okay, so moving to the distributed control system. Now, whatever I've been talking through, I think you are aware that from a cross platform support per se, obviously we can use a single distributed system irrespective of what I'm using or which system, which operating system I'm using. It should be well versed with that. Similarly, as I said, if you are not using if distributed version control system, you will be missing on the reviews and the pull request which I am talking about, or in simple sense the code merge utility, okay, or code merge facility which you may get out of box from the distributed system. Okay, so remember, obviously there are pros and cons, but today it has become must that there are in an agile system especially, and if you are an enterprise, there are n number of developers working on their own development codes. We need this distributed control system. We need a branching strategy which takes care of that. Similarly, we need a strong review control system which helps us get that, and this is available with a portable history in the distributed control system. And if you see the strength as well, this talks all same things. Similarly, where it is best used for, it is used for small and modular code base evolving through open source highly distributed teams. So here, even though it is a small and modular code base, the reason that is written is now today each layer of your development can be distributed, like say suppose front end being developed in Java, or I would say Angular. Similarly, your back end being Java, so you can keep small and medium, so it is manageable. From that, say it distributed control system is very good. But if you want to really have a permission management or a single permission control, then in that case you have to go with a centralized and large, which is able to handle the large repositories. But you will lose on the review system or even the code, the merging of your code from the different trunk based branches. Okay, so obviously there are ifs and buts also. We have seen that what is best used for today. Even you go for the smaller systems or applications which you are designing, they follow a microservice based approach than monolithic approach. So that those all things you have to keep in mind before selecting a source control system. Okay, because what happens today is each and every system services should be independent of others. So that again points us back to small and modular code base. So we are able to manage that rather than having one single chunk in one particular repository, which was in centralized system. Okay. So make sure you understand the difference and why we are having this as a distributed control system in today's world. Okay, and obviously some of the examples of that are Mercurial, Git, and Bazaar. So these are some examples, but what we are talking in today's session is all Git based, or also what 95% of the people are doing around the world is on the Git based systems only. Okay, so from an exam point of view, you only need to be aware of Git based systems, that's it. Okay, so don't worry about any others but from the knowledge per se, you should be aware of that. Okay, so again I will pause here for a while before we move further. Okay, so now coming to the branching strategy, I think we talked about in our first session, but here we will talk more on how we are actually going to implement that. Okay, so from a first session, we are aware that first loop, whatever you are seeing from a development and testing, this is more from a development per se. And we have different branches for feature one and feature two, which are short-lived branch. A development is our main branch, which for which we are going to have from feature one we are going to have review and merge it back to the development branch. So this is the bare minimum, and whatever we've been talking about, what is available from feature one, feature two, including the production branch, they have to be tested. Hence we have a separate branch for testing. So that is the bare minimum from a development as an approach. Okay, so that is what we have, the feature branching. A new feature development should be in dedicated branch. So that is what we are talking here. Similarly for release, so strict branching model designed around project release, because this is more to do with a platform where you're going to deploy your code or package. Okay, so in that case, if it is for system, obviously you will come across for the hot fixes, or will you coming for the service pack, because now this is more towards an operating system related fixes or an application related fixes along with the service before I can deploy my code. Like say example you can take is if you have some install any web server. Okay, so a web server you need to have appropriate hot fixes. Similarly, you need to have appropriate service packs before you can deploy the code on that particular web server. So this is purely on releases, whether you are in the development, whether you are in the test, pre-production or production. I think the release should have the strict control or model where not only you deploy it in a seamless way, but it is very well tested before it moves to the production, and you can also have the approvals in place. So this is bare minimum from a strategy per se. So you have two branching strategies. One is for your release from a development per se, or I would say a development feature based strategy. Second is your release based strategy. Okay, so that's all you should have. Okay, so I think this, as we covered in our first session as well, should be clear by now. So I'm moving ahead in interest of time. Now, whatever we have been creating from a repository, we have two options. One is clone versus fork. Now, what is clone and other is what is fork. So in bare minimum, clone is a copy of any repository that may be available either publicly, or even if you are on your own system and copying your own repository, you should be able to clone that. So ideally it is a copy. Advantage, it has complete history of whatever you have done in your original repository. The disadvantage is every time you want to have, there is no connection between your original repository and your new repository. Because why it doesn't have? Because if I want to, I am having clone, I should get full copy. Otherwise, I have to fork it. Okay, so the difference between fork and clone is if I want to manage the independent copy, then I clone it. But if I want to comment or I want to collaborate, contribute toward the original repository, then I should fork it. So that is the simplest meaning for clone versus fork. Now going through these bulleted points, just we can recall what I have been saying for clone and fork. Okay, so cloning can be on server, your GitHub account, or locally on your machine. Similarly, you get every developer have their own server side with full access and obviously the history as well, so that whatever comments you have made, they are independent. So here you clearly say that server copy with original as both are independent. You cannot sync directly because there you have made sure that you want to clone it, not have the fork of it. Okay, while cloning, you select whether a repository will be public or private. Typically follows a branching model, which is gateway. Now branching is something which we have talked just now. Okay, so while you clone, I think it clearly tells you what kind of the uh, model you will follow. Okay, so most of them follow the git flow based model, not git flow, because that is very strict and it has only one production branch with a feature branches, one or two. Okay, so make sure you understand these terminologies from session one as well, so that while we pick up in our next sessions, you should be very well versed with those terminologies and are able to use it. Okay, so cloning is whatever. So again, just go through them. So forking, it gives every developer their own server side repository, but make sure that you understand now you have the two repositories. One is your own local one where you are commenting, another is a public server side repository where you are actually trying to make or contribution to. Okay, now anything and everything you want to contribute towards, you are actually having kind of a complete history, and while you raise the pull request, you are actually going to merge it to the original repository. So this is the best way where all the developers across your organization will be working with the help of the fork, so that irrespective of who changes what, you are first aware of the local copy. The advantage you get is you all things are in sync. If anything gets changed on the original repository, you are aware of that, and simultaneously you as a developer are able to contribute. So this is the best thing which any particular enterprise organization will require. Okay, but if you are working pure completely different, or I would say a completely different code, then obviously you won't need the the forking unless and until you are contributing towards that repository. Okay, so make sure you understand that if you as an organization are working with a number of developers, so they are aware of what's happening across the team, who is developing what, so for that fork is necessary. Okay, so I think I will pause there for a while so that you go through these bulleted points, and then accordingly we'll move further. Okay, I think we should be good to go. Now, this also we will see practically. Like uh, once I cover this, I think if you see the branch policies, merge restriction and protection, these are very important in terms of how are we going to actually have a protection. That means why we need protection at first place, because today even though developers are working in their branch, if I don't block them from committing unless and until it is being reviewed, it will be accidental, like I would say a catastrophic event occurring, like we are overwritten something which was working before and not working now. It can happen, right? So for that, I think if you have already worked with any of your cloning a repository and working on any branch, so I'm just taking example of Azure DevOps here. So I have three branches. One is feature, one is main, and test. So main is a branch which I want to protect. Okay. So in that case, practically what I will do is I will go and click on the branch policies and see what things are available to me from the policy. Now these are the settings which you need to be aware from exam point of view as well. Okay. Even though they will not ask you the labs on that, but I think at least you should be aware that these settings are available. Okay. So that you are able to lock the branches uh, while you are working on the production system. So I can select the number of minimum reviewers. So by default, it goes for two, but I think in many cases, if you are short of team, you will select allow requester to approve the changes. But in an enterprise system, you won't be doing that because reviewer should be different than actual requester. Similarly, prohibit the most recent pusher from approving their own changes. Okay, again, this relates to the whoever has push approving their own changes. Allow completion even if some viewer vote to wait or reject. That means I can say the condition, instead of waiting for minimum reviewers, I would allow still even one has done, whether they are waiting for an approval or not. Okay, so I want this to happen when new changes are pushed, and I require at least a one approval from the iteration. That means if even if one person approves this review a request, I should be able to merge it to my production branch. Okay, so these are the options. You can try it out. I won't be able to read, but I think you can have a look at while I'm scrolling it slowly. Okay, now at this point of time, this is on. That means uh, every pull request is being blocked unless we have one linked work item. Okay, that means from a traceability per se. Okay, so unless it is reviewed, or if I can put it, if I want to optional, then it should be able to allow a merge directly. Okay, so similarly, if I want to have on for comment resolution, I want to make sure that none of the all the comments are active and is being closed. Okay, blocked from being completed while any comments are active. That means if anything is being worked on still, or if someone is still typing and having their own comments, I think there should not be in progress kind of thing. Okay, so you have to accordingly wisely choose the options. And this is the merge types. I think this you might be pretty much aware of, so won't be going into detail about this, but I think if you see the description, should be you should be able to make out what they are. Okay, preserve exactly what that was. Linear by conducting this new comment. That means what whenever I actually comment it, I want to make sure that all I'm going to merge all of them into single comment from the previous, so that if say suppose 1 year down the line I don't want all of the from all history to be maintained, so I can do that. Rebase and fast forward. That means even though I did a linear one, but now I want to redo replaying the source branch commit, so that now I start fresh from here. Okay, without merge. Okay, so I'm rebasing from where I want to actually uh, start populating history. Now this whatever was lacking will be done with rebase the merge commit. So ideally this is the first where I merge it in a single commit. Here I rebase it that I'm starting from the new point, but here this is a mix of both. That means I'm rebasing it to, but I want also want the a merge commit to be available. That means whatever I have truncated, I'm now starting from that particular merge commit per se. Okay, so this is what you have from the branch policies. If applied, I think no one will be able to merge that until it meets all these criteria. Okay, so make sure you wisely select that and you understand what we are trying to do here. As I said, again, there is no practical on that, but at least you can go through in your own DevOps system. You just go through this so that you are making sense out of it. Okay, similarly, while you are working on the pipelines, I think you will see how we can have a build validation. Okay, if it is on, what that means and what kind of the status check you can have. Okay, so status checks, I think whether this particular, say suppose I cover this, and what policy at least this should be succeeded, and in advance I can see the status. Okay, so there are n number of things which you should be aware of, and there may be time when you know that already the team members or that particular team group, so you should be able to add the reviewers or groups here directly as a reviewers. Okay, so make sure you understand each and every terminology here, and best way is you try it on your own and then go through that at your own pace and then complete it out. Okay, so this was for your branch protection policies. Okay, so same thing, I think if you come to your code base for, you can go through the pull request and issues along with the branch policies in GitHub as well. Okay, so if you see the branches, okay, you had a branch set rule. Okay, so you have to give the rule set name. The only thing at this point of time blocking is I'm doing this from my own personal repository, but it requires at least a team organization for me to have this practically. So if you are in an enterprise environment, should not be a problem. But for me, I think at this point of time, I will not be able to create this rule set, or in simple sense apply that. But at least I can show you what that rule set means. So if suppose I'm applying the branching. Okay, So just to give you them an enforcement status, I have to select active. Okay. So and bypassed, if I really want to bypass any specific admin, any particular user, I can do that. But ideally I want to make sure that I'm including the branches which I want to have the protection for. So I will say include all branches. Okay. So by default I will apply say default branch, which should be master, main, or whatever you may have. And the branching rules, whatever you have seen in Azure DevOps, is obviously different here. So here you can, based on who is commenting, who is providing updates, whether you want to have linear history or whether you want to have merge commit squad. So here by default, as I said, prevent merge commits from being pushed to a references. Okay, so by default, if you, this requires a linear history, which is the default which you might be seeing, which is happening across the globe. So because you don't want to miss any update, so that is what is, that is a must before you comment. Otherwise, this will not be able to succeed in there while you raise a pull request and merge your feature branch to the production branch. Okay, similarly, you require deployments to be succeeded, and there are other things for prevent user with push access from force pushing to reference. Because what happens is, we, even though we have an access and we want to forcefully push because something is pending to be resolved, so they should not allow that from unless that is resolved. So which, that is what I was talking manually, right? So it's suppose if there is any conflict of your comment and then you want to force push and ignoring that, so that should not happen, is what that means. Okay. And the other thing is, from security per se, I think we will cover more in the security code scanning results. So unless and until the code scanning is clean, I don't want you to push this to my production branch. Okay. So this is what is a rule set. The naming is different here. You have a policies. Okay. Remember here, I think again I will go back to the branches, so that, okay, so here you have gone to repositories and branches, and from branches you are having creating branch policies. Okay, so that is what we did. And coming to the GitHub, I think you have covered a rule set, which is in settings. Remember, you require the team organization minimum to apply this rule set. uh, okay. So team, while there is again, I'm repeating, while there is no practical, if you try this on your own, I think this will make more sense and you will understand each and every terminology. But I'm actually providing you the pointers what you have to try out before you sit for the exam. Okay. So this particular, whether you are working with the branches or policies, and that is what will be helpful. Okay. So similarly, I think let me check if there is. Yeah, okay, I will show you the pull request as well. So suppose I had two branches. Okay, so I'm just leaving it from here. So I have two branches here. One is master and another is feature. I had done changes on README file here. Okay, so README file here in feature, I have changed it to, I have added some comments, and based on that I have raised the pull request. Now pull request will give you what exactly in terms of comments. First of all, that if you have the specific comment like what you change, I have updated readme, but what I have done is, I think you should be able to check on file change. So I had added the feature branch is what, and so this is the new and this is what I have removed. Okay, so something which is red is what I've removed, and something which is green is what I've added. So while going back to the reviewing changes, I can merge now to the main branch. Now at this point of time, if you see, we are having readme exam prep expert. And similarly, if I move this to the feature branch, read me to the feature branch, I have feature branch. Now let us merge this request. Okay, so I'm merging this, confirming the merge. Okay, you are all set. That means this has been now successfully committed and the file is changed now. Okay, so now for me to make sure that this has happened, I have to come see. So while this was a short demo, but I think you should be able to make out that what exactly is changing while you are raising, and pull request is closed now. You don't have any pull request now. So that is what, if things are good, are being reviewed, you should be able to do it properly. Similarly, say suppose I did this for any specific a project, a module, I can apply specific labels as well. Something I fixed my bug and now this is fixed and I've committed back to the production, or I would say I merged back to the production. Similarly, this was an enhancement, good first issue, any help on it. So these are the labels you can also apply to make a category for your team, so that, or I would say red team versus blue team versus whoever is working, if you are working on a security related issue. Similarly, if you are a developer tester, make sure you apply labels as well. You can also apply milestone if you are strict on the timelines and you want to have the product flow. So those milestones also you can create and accordingly apply. Okay, so if you see, not from here, I think from labels you should be able to make out. If you create on labels, it gives you first is for labels. Few for milestones, you can also create one milestone here with an appropriate timeline and then apply that milestone coming back to your issues or respective. So anything and everything else, suppose this is what I did for an issue. If I successfully close that, I can close the issue. Okay, and this is from the project management per se. We have kept this in the backlog, so I would say issue good to close. Okay, so if you close this with comment, so you are good. Okay, now this authentication issue was there as from the project management. See, the status is turned to done. Previously it was showing the backlog. So this is what we were talking about, a hand to hand. While we are working and closing the issues, our project management tool should be smart enough to convert that to a closed state or done state. Previously it was showing as a bug, right? Or backlog, not bug, backlog, sorry. Right, so it has done it automatically because it has seen that this issue is closed. So this is the again the topic which we want to cover, from the how we want to merge it, how we work with pull request, how we want to get rid of any particular redundancy in terms of applying a proper approach towards merging. Okay, and it should follow like from labeling per se or from milestone per se. If you are a product, you should apply that as well. Okay, so from branch policy, merge restrictions and protection, that's all. And this is I'm just showing you what we just talked about. This is exactly the same thing. Similarly, for your bronze protection, we clearly see that how this should be merged and what are the requirements from the GitHub as well. So this was a short snap of that, whatever we have seen in our practical demo. Okay, now till now what we have covered so far is our branching strategy, what are the source control systems available to us, and then finally what we are trying to make out with help of cloning and forking and locking the branches with appropriate, so that no one should be able to merge it without our permission or approvals. Okay, that till now we have covered that. Now how do we decide really when we want a single repository versus multiple repository? Now take a simple example of a centralized ecosystem where everything is in one repository. Now you don't have any segregation between by the technology stack. You don't have segregation by In that case, it will be very difficult to manage everything in a single repository when the technological stacks like front end is in Angular, but your back end is in Java. So the complexity is even though you have the branching, but they are distinct branching. That means there is no way to merge, there is no way to collaborate. Irrespective of what branches I'm using, this will always cause a conflict. In that case, it is very difficult, or I would say it becomes important to move the Java to one single stack for that particular project or module in one repository versus the front end, which is Angular, in another repository. Okay, that way I can collaborate and see the linear history which I'm expecting. So everything is small and manageable, or I would say medium and manageable. As you move large, the history, see here, remember, you are having history at each file level, not at repository level, not at the branch level. Make sure the complexity, you are, if you are doing 100 comments a week or even 1,000 comments a week, how difficult it will be for you to really make out what was done even a month back. It's very difficult. So make sure you are following appropriate merge strategy, how you're going to review your code, and finally, most important, before even starting with the code, make sure that you are having an appropriate repository and they are clearly segregated and separate based on the technology stack, and something which is not overlapping, they can go in parallel and have a separate repository. Just for sake of keeping everything and one repository doesn't make sense if they don't have any role to play in merging, any role to play while having the code reviews. Okay, so make sure you understand this, and based on that you select the single repo versus multiple repo. So that is what I think here in advantages it clearly shows. If you really want clear ownership permission, go for a single repo and having the narrow clones. That means you are only working on that set. Okay, multiple repositories reduce code complexity, obviously. Effective code reviews, because as I said, if you yourself are able to maintain the history in a clean way and understandable, documented, so that there is no conflict and the right team is working on the right repositories, there is no confusion at all, and you are able to refactor it easily, right? Obviously that this makes sense. Okay, so this was for single repo versus. Now, while the way we covered merging, it is also important to know what kind of the permissions are available to you out of box. Now, for Azure DevOps, I will open up for Azure DevOps. Similarly for GitHub repo, I could have shown you practically, but that will take a lot of time, and I won't be able to cover each and every terminology. That is the reason I'm taking help with this, whatever the articles available out of box. Now, this is for Azure DevOps. At project level, what kind of the permissions are available? A basic, right? So these are the permissions for your private projects. Similarly, at the repository level, you have readers, contributors, build admins, and project admins, and what they can do out of box on that particular repository is what listed at left. Okay, at right leftmost, read, contribute, delete, create repository, delete repository, and rename. So if you see clearly, project admin should be able to do all. Okay, bill admin should be able to have the branches created and manage the branches till the branch level, but for the repository level permission, I think you only have the project admins. So this particular helps you getting you not only get the terminologies right, but I think you should be able to also do a step by step article for you to follow this. While I may be doing in a very short, but this may be giving you more info. That is the reason I have kept this article itself while showing the permissions. Okay, if you click on the security, you should be able to see who has an access and what team members are having access. You can set the permissions based on what they want to do. And remember, you may see bypass. Bypass is only for if you really want that specific admin should not be blocked from commenting, because you know this is an approver, so they should not be blocked for irrespective of there is approvals present or not. So ideally, not a scenario which you will see in enterprise, but at times you may require that if this project is just started and you don't want any hiccups at start, so you may bypass during that time. Otherwise, uh, if you have kept or everything in mind or while designing the branching strategy, who will review, who will be the reviewers, minimum reviewers, and what kind of the comments you are looking at, and so those all things will make up your complete strategy for merging. Okay, so make sure you understand these terminologies and who or what kind of the permissions you are can be able to set and at what level. Okay, this is at more of a repository level for the contributor. Similarly, at the user, who is the user, so you can also disable the inheritance. That means if I'm using the respective version control system. Okay, now this is inheritance is more from if you are a user is set at the not project level, at the organization level, so those will inherit it automatically. So if you want to be very specific on blocking those users at the project level, you can do that. Okay, so enforcement, bypass policy when completing pull request for a specific overrides while pushing. So this can also be same, like you are allowed to complete the pull request, that means override anything, but while pushing directly to specific branches you may block. Okay, so I think there is the settings available to you out of box. Okay, so from permissions, I think this is pretty much what you want to do on your repositories. Okay, so this is bare minimum you should know for the exam, the terminology and how you do that. Okay, now similarly is for your GitHub. See, while the terminology and the namings, or I would say the title may vary, but I think at the end of the day, you know that you are doing the same thing. Only thing, it being the two different products from DevOps, you have to uh, move accordingly. Okay. So now here you have the read, triage. So there you have contributors directly. You have for triage. Similarly, you only have to write. That means you are only pushing because you are a developer just maintaining. You will not have any permissions on merging anything. Similarly, maintain for the project managers because they are working on any sensitive, or so they are able to have the. So remember, this is cumulative. Like if I have the triage, then obviously I have the triage, then the read access. Okay, so this will be cumulative access. Maintain, then admin obviously can do everything. So this is the repository roles for an organization. Similarly, at each role, the way we have seen in Azure DevOps, you can see that you are able to have these read, triage, write, maintain, and admin. Similarly, there you are having the from if you see the you are having the readers, contributor, build admins, and project admins. So just make sure you get the terminologies right while going for the exam. Okay, so this was about the permissioning. Similarly, I think I have shown you how the tags look like, but here again I can let me close this first. So similarly, if you are working on Azure Repos, why you should use tags, I think I've clearly mentioned. If you want to group your work according to the month, different teams working on that, you can obviously apply the tags. And this article is giving you a step-by-step procedure to apply the tags. Okay, that is the reason I'm showing you here, that you should be able to see for what you need the tag specific to, for any particular comments or any particular issue you are resolving, or even I would say if someone wants to lock, I would say that okay, after this comment apply this tag so that from here onwards this issue is fixed. So that way you can also see version 1, version 2 applied by last comment, where you are, so you have succeeded your deployment, you would apply the tag and create a uh, create a branch from that tag. First you apply the tag and create a new branch from that. That is also available. If you see here, while I'm showing is for delete, but I think you have these options: new branch, download this as a zip, view files, view history, delete a tag and get. So you can actually create a new branch if you are sure that this has been worked successfully very well. Okay. So here I think it is whatever I was talking about, that this I know has this comment. After this comment everything is fixed for this issue. Better create a new branch from here so that now everyone is working on the production thing and we are able to going clean from here for that particular feature or that particular issue which is resolved. Okay. So make sure that these particular articles which I'm showing you thoroughly following them and applying it to your fullest extent. Again, for from the GitHub repositories as well, you should be able to apply your tags. Okay, your release tags or if any work you are doing on that particular. So that completes your the permissioning and the tags, which is also important, equally important for your repositories or any particular thing which you are working. So you are now aware of whether you want to have a branch policy, how you want to have restrictions in place for both. You know why you selecting single repo versus multiple repositories, permissioning and the tagging. Okay. Now we move to the recovery files in repository. Now remember, till now whatever we have done, it was purely the UI. Okay, that means everything what we did was available in the actually your, either you have gone to the dashboard which is on Azure DevOps dashboard or you have used the GitHub related portal. Okay, but from here onwards it becomes important that you know the command lines. The reason is because in UI it is not possible to portray that. Also, it is not possible to show you the history of, even though you may see history to a limited extent, but if it is going for a year or so, it's very difficult to actually go through them and even search for those comments or hash codes. So that is where I think for any recovery related, you first of all needs to go through logs. Okay, once you go through logs, you should be able to find out which comment you are trying to find out and filter it out based on what you are trying to find out. Similarly is your checkout. Okay, while you check out, I think you are actually trying to comment that particular, say suppose I have deleted, incidentally deleted a file, so I have to select the hash code, say from, I will give you example like in our repositories itself. Say if I go to the I can show you in our code. So if you go to the, okay, so here you have history. So for each you have hash code. This is what I was talking. Okay, so this code is where you should be knowing with the help of git log that what exactly, suppose I have deleted one particular file. Okay, before, so I should be able to select this. If I have deleted file here, I should be able to select this tag. This will give me the complete history or whatever I have, the I can say snapshot of that file system before that. Okay, so that is what is meant by the whatever I was trying to make sure that this particular git logs and checkout. Okay, so check out with that particular hash tag which I have told you, it should be available for us. Okay, so again cherry pick is something which if I want to move out with only particular comment and ignore anything else, so that I can do with a cherry pick. But to give you these, I think recovering or a specific line of code, how you work on the git show for that from that particular file or comment. Similarly, recovering files with, see there are different ways to recover. One is at cherry pick or the or commit by commit level, and other thing is recovering complete files and also recovering your branches or specific file system related checks. Okay, so this is what they are. So important thing for you is go through these command line options. That is the reason I have kept in this particular as a cheat sheet. So if you try to download this cheat sheet, I will open it up So this gives you, I think you can download PDF as well. So we want it for English, right? So here it gives you step by step options how you can get started. Okay, so for Git configs all. Okay, so right from working on your configs, then the branches, then making changes with the help of logs. What you want to have the differentiate between the git show command, which you have seen, git comment command with the descriptive message. Okay, then redo something, that means reset it. That means I'm trying to make sure that this whatever changes are done, I've reset it to a hard commit to this so that that history is gone. Okay, so make sure while you are taking these steps or actions, you are aware of what kind of uh, the action you are taking, because otherwise it will create a lot of problem for you. Similarly, while you are synchronizing changes, you want to fetch, similarly you want to merge, push, pull, make sure you know how you want to use this with the help of these git. Okay, so this particular cheat sheet I think you can get from either you google it around, or or you go through the github. You should be able to work it out yourself. Okay, so make sure you understand what we are trying to do and follow it accordingly. Okay, now important thing is till now here you are recovering these files. I think you have the command lines which you are doing yourself or getting help from the team to know what is going wrong, or how do we recover the branches, repositories versus the commits or specific files itself. Okay, so that is what we are want to recover out of box. But what if I have committed the sensitive data? Now to remove that, I have a git filter repo. This is a tool which I can use it, and with help of this tool, because this becomes very critical. If I want to remove the sensitive data, I need some tool which can do the things for me, even though this is a command line, but we call it the tool because this has its own purpose. Okay, so what we want to do here is, say suppose I have commented something which I should not have commented, but by the nature the way we are in distributed control system, someone might have clone, someone might have fork, hence it becomes very difficult, and we need a coordination from all team members to remove something which is commented. Because if they have forked, they have already got that. If they have cloned, they have already having the independent copy. You should not be able to delete if even if you are committed by mistake. Okay, so that is what it is important to understand this tool. Okay, and understand the history. Make sure we are able to overwrite the history or remove those even changes of the history, because again, if you have kept the history in some way or other, if someone comments it back to the previous line, the way we did for recovering the comment or recovering that particular file, then they should be able to recover it without your help. Okay, to prevent this, I think what you want to do is you have to take the steps step by step. Okay, first is using this repo tool. Okay, then going through the return history of where you see that you have commented the that particular file or the password, then you remove or go to the previous comment where you are clean from that comment, so you want to restore it to that level. Okay, so that you can go and clean up. So again, for this, before you move towards like the actual cleaning up yourself, first thing is you need to make sure that if you do on your own, then obviously there is a chances if someone has clone and fork, they will be able to still have that in their repositories. So you cannot remove the sensitive data from others users clone is what this bulleted points are talking about. Similarly, there will be some cache references which you have to raise a support call with the GitHub team, because these all things are deciding on the servers. Server will have local copy before getting commented to the file shares. Okay, so make sure you understand this terminology. If you want to remove something, the process is very tedious and you have to follow step by step. Hence, again, for this I have the manual which you can refer directly. This is a git filter repository manual. it talks about what it does. It rewrites. Why rewrite? Because I want to remove that comment where I have incidentally committed something or incidentally put on that particular file. Unless I rewrite, I will not be able to delete that completely. Okay, so if I want to remove some history comment, then I want to rewrite the logs, rewrite the history logs. So that is what this is very crucial. Now you can read out the description, but in short, I have already told you that I want to delete something which I have committed by mistake, and it should be cleaned from my clone repositories, from the fork repositories. How do I do that? I think there is a step-by-step procedure for rewriting this. So here is the rewrite procedure. I'm just coming to that, just a minute. This is just an info on how we are doing this. I'm just coming to the rebase thing. Yeah. So from here onwards, and this is the practical how you use this tool. Okay, so if any file, anything you have committed, just go through the log all for that particular file. Okay, and then make sure you have a local copy of that, clean that, and then recommit it back is what they will tell you. Okay, because you you don't do directly on the server. First you should be aware that you did it correctly and then replay it back on your server. Okay, so it gives you step-by-step option of how we are doing this. So in interest of time, I could not do this because this will take at least an hour or so. But if you go through this description yourself about how this tool is working, I think this is pretty much you should know even for your production use cases. Okay, you should be fine. There is nothing more than this git filter tool apart from whatever I'm showing. So make sure you understand what we are trying to do here. Okay, now this is something which you have been now till this time we have covered this remove sensitive data from source control. Okay, now last is scalar. Now why we need scalar? This is an optimization tool especially for the larger repositories. Now the problem with the larger repository, especially in the Windows based system and the Mac, we have the file shares which does an IO operations. So if your history is very large, these IO operation can take long. Okay, so make sure these whatever the IO operation we have been talking about. So these particular IO operations will help you to know what kind of complexity you have on your system. And then while you have this tool, you can run these commands to optimize your larger repositories. So first is registration. You can register your tool after downloading with your repository, and then you can run all means you can optimize either only one particular or run all the optimization commands. Okay, so if you see what it does is optimize your the repository structure, break down larger repositories into smaller ones, adopt a modular approach, use Git submodules and Git. So ideally this it does it for a repository level or across cross based on how you have linked your code base. Okay. Similarly, if you see, I think better to open up the manual so that you are aware how this looks like. So I think you can read out the description. I will won't go more. So while you do, I'm just highlighting the key things. Time spent for waiting for the get status versus get fetch can become larger for the larger repositories. Okay, because it has to fetch everything. Similarly, if you really want to have this corrected, you download the scalar tool if you are on Windows or Mac, and then have these commands just to know that scalar is installed, and then register the scalar with your repositories at your local store. And once you do that, I think it will be just a matter of applying these commands or optimizing your repositories and then commenting back to your original repository so that you know that the repository is optimized from the IO perspective or from the file share hiccups. Okay, so while it's a small thing to do, but I think this process itself takes some time. Okay, similarly, I think this is genome. virtual file system. The previously the VFS or GFS, whatever you are talking about here, these are more of a virtual file system, and it also helps you if you don't want to do directly, you can clone it and then do it for on the separate. But at the end of the day, this is what we are doing. So this keeps on populating, and while you index it as well, this takes a time. That is the reason while you run the git status and the git fetch command, it takes a considerable time. Okay, so go through this document. I think, as I said, in interest of time, I won't be able to give you each and every, but I think this is pretty much elaborative. You won't need anything more than this to carry out. See, these are more of how I'm organizing the files on my track. Okay, this is on virtual file system. Remember, this is how they are kept on the your storage. Okay, so that's all we have for this session 2. Okay, so just to recap what we covered in session 1. Session 1 was more on the on how the project management or what is our DevOps strategy. Then we have completed with how do we collaborate, what are the work items versus bugs, epics, and all those things. We talked about a lot of the terminologies which make sure that we understand that the DevOps very well. And then from there onwards in today's session, we covered the source control, what are the type of the source control system, and then pretty much everything around the, because source control system is the heart of everything we do in and out on the DevOps. Okay, by this pipe. And then design strategy, the difference between the terminology of cloning versus forking, how we work on the pull request policies, how to keep our branches secure, selecting repositories, then having a tags, removing the sensitive data or recovering the sensitive data from whichever being accidentally deleted or something which is accidentally populated. We want to remove that. Finally, scaler to optimize the IO operations of GitHub status versus fetch. So basically, you whether even getting the logs around that, we want to make sure our index or optimizes, our file system is optimized if the repositories are large. So that's all. Thanks for joining. Have a nice day.